Okay, this is just an audio test. This is just an audio test just to make sure that technology works fine. Hi, Stefan. Hi, Jan-Erik. Can you hear me?
Yes, I can.
Let's do a quick tech check. We still have 5 minutes before we are going to start.
Sure.
We can hear you. That is good. Can you try to share your screen just to make sure that this works too?
Yeah. Let me find the right window. Which one is it? I think it should be that one. There you go.
Yes, here we are.
Well, maybe I should start the first slide.
Looks good.
All right.
Yeah, I think we are ready to go. I will take us from the stage for another few minutes until 5:30 sharp. Then we will do a quick community news intro. It will take today maybe a few minutes more because we have 2 tickets. Or Stefan, what do you think? Should we give the tickets away between the talks or at the beginning? Between the talks? Yeah, okay, so let's do that between the talks. So I will just do a quick intro into community news and things like that, and then I can hand over to you. I will get you to the stage, and we'll start, okay?
Perfect. One question. Will attendees have any chance to post questions, or is there...
Absolutely. They have. In your presenter studio, you should see the comments section.
Okay.
And the questions that come up in YouTube will be in the comment section. And if you want, we can also relay questions that come in through Discord to you.
Yeah, that would be nice. At the end of the talk, there should be a bit of time for that.
Okay.
And just
awesome.
Double check. I got 30 minutes, right?
You have even more, so you can use whatever you want. No, not whatever you want.
No, I'm prepared for 30 minutes. I just want to make sure.
That sounds great. We have 45 minutes between you and Herbert. Let's take Herbert to the stage so we are all together and we can discuss that because I think he's already here. Hi, Herbert. Hi.
Hi, give me one second. I'm just getting set up here, so...
Yeah, no problem. I just wanted to take you on the stage. We still have a few minutes to go, just to discuss the procedure. Jan-Erik, you asked whether 30 minutes are okay. It's perfectly okay. So we have 45 minutes, and we have the ruffle just in between the 2 sessions. So if you have approximately 30 minutes, then we can do maybe a Q&A for a few minutes. Then we have a few minutes for giving away the 2 tickets for the Rust Day, and then it's all up to Herbert, and the stage will be his. Is that okay for you?
That sounds good. Thank you. I'll be in and out for the next few minutes. I've got to take care of the dogs and do just make sure they stop barking. So.
That's when you push the wrong button. I'm sorry.
Yeah, absolutely. No problem. Did you hear what I say?
Yeah.
Concerning the timing?
Yeah.
Perfect. Okay, so then I will take us off the stage for the last few minutes. We'll let the intro video run through, and then we'll get going, okay?
Sounds good. Thank you.
See you in a few minutes. See you. Hello and welcome to the Rust Linz Meetup. We are very happy that we have you again here. We have an exciting program today and it's now 5:30 here in Linz in Austria. So we will, as announced, start with the community news. We'll take a few minutes to take a look at what's going on in the IT community here in Linz. And well, today everything is virtual. So wherever you are, you can definitely join all these community events. Let me share my screen with you so I can share the presentation that I have prepared, and yeah, then I'll just walk you through. So here is my presentation, and here is this one, and let's put that one on the screen. That is good. And with that, let's get started. Yeah, welcome to the 9th Linz meetup. Next time we have the 10th. So we have 10 meetups already. We are looking forward to that. The Rust meetup is brought to you by our local coding club, Coding Club Linz. I have the honor to be the chairman of this coding club, and we are happy to do a lot of community work here in this town of Linz, which is right in the middle of Austria. If you are not familiar with Austria, Linz is pretty much in the middle of Austria. Today, we have two speakers coming up. We have Jan-Erik, who will tell us a little bit about leveraging Rust to build cross-platform mobile libraries. And we're looking forward to that. And the second speaker will visit us from the United States. Herbert Wolverson will talk to us about learning Rust with game development. To be honest, this is a talk that fits perfectly into our setup, because here at the Coding Club, we do especially one thing too. We do programming with kids, and whenever we do coding with kids, learning by playful approaching a technology, by building games, is a very important part of our work, and we are glad that Herbert and Jan-Erik took the time to talk to us about Rust, and from Herbert we will hear about game development. Now, for those of you who are with us for the first time, you can use the YouTube comments window to ask questions. The speakers will see your questions and can answer them. You can also, and you are invited to join our Discord server. A lot of people have already joined our Discord server, the more the merrier. You are invited to join our Discord server too. Here you have the link, and there you can also ask questions, and I'm going to relay questions that you ask through Discord to our speakers to make sure that that all your questions get answered. We also invited our two speakers on our Discord server, and I think they are already on the server too. So maybe you can take the time and the opportunity to ask questions directly to them and tell them whether you liked, you will probably like their presentation. They will be glad to hear that. With that, let's go right into the community news. And the first one is a very special one. Let me tell you a little bit about why I have this one up here. A few weeks ago, we approached a German publishing house and asked them if it wouldn't be a nice thing to have a full day Rust event, a kind of mini Rust conference or a Rust day or something like this. And we were very happy when they said, yes, they are going to try it. And now we have next week on the 28th of April, we have a full day full of Rust. And let me quickly show you the program of that day. I have opened it up here on my screen. This is this Rust day. If you scroll down, you will see who will speak there. Ryan Levick will do the first session. Then we have Arno Hase. Then somebody who I might know, Rainer Stropek. I will do a session there too. Then we have Katharina Fay and we have Ashley Williams coming up. So we have a day fully packed with content regarding Rust. And the Software and Support Media Publishing House was nice, and they gave us 2 free tickets, which we will give away in a raffle today between the sessions. So if you would like to join this day 100% free, then stay with us, and between the 2 talks we will draw winners. And if you are present and if you are a winner, you can have a full day free ticket for this Rust day on the 28th of April. Now to the Linz community, to the local community. This local community our programming club will organize the next Coder Dojo. It is a programming club for kids between 8 and 17 tomorrow, as every Friday. For those of you who are new, the Coder Dojo is a programming club for kids, which we have been doing for over 5, nearly 6 years now. And every week we meet with kids for various workshops. No, we are not doing Rust with the kids yet, but we are thinking about how we could do that. No, we do things like, for instance, Scratch and Minecraft and Java, JavaScript, TypeScript, and many other things. So if you are interested, you can always join us as a mentor, but you can also tell your kids or your relatives or your friends about this offering. It's 100% free. It's virtual, so you can join us from wherever you are and code with us. The only thing that you should be capable of is reading German and talking German, because the programming club is in German. Now, our friends at the Female Coders, let's make that a little bit larger here. Our friends at the Female Coders do a workshop day. It will be in a few days on April 24th. I hear they are pretty well booked already, so it will be a very exciting day. So if you are a woman or a girl at the age 15 plus and you're interested in coding, maybe you want to learn it, maybe you are already an experienced coder, then you are invited to come to our friends of Female Coders. It's a community here in Linz. It's the Linz Female Coders, and they are going to do their workshop day. If you want to know more, here I have the link. If you want, I can share the presentation with you through GitHub, so you have all the links maybe in a PDF or something like this. And the next one is from our friends at the Cloud Native Computing Meetup. They were also founded during the Corona time, and they started their Cloud Native Computing Meetup a few months after we started the Rust Meetup. And of course, we know them pretty well, and we have a lot of exchange going on between the Cloud Native Computing Meetup and us. And they will have their 7th Cloud Native Computing Meetup on the 27th of April with an exciting speaker lineup. Take a look at their Meetup page. Again, it's virtual, so if you find it interesting and you are even from the other end of the world, you can still join us or join them and join the discussion and listen to the talks that they organize. Now, the next meetup after Rust Meetup is before Rust Meetup, so I can also announce today the next meetup that we will have. So note it immediately. That would be the best in your calendar, that our next meetup here in Linz will be the 27th of May, and we already have the speaker lineup finished here. We will have three guest speakers. The first session will be from Lisa Passing. She will talk about creative Rust. Will be very exciting, and we are glad to have Lisa. And the second one is two people from a company from Vienna, Harald Reingruber and Katharina Unger. They use Rust for medical visualization, and in their talk, they are going to tell us why. They are going to tell us how they use Rust and why they use Rust. They will share their experiences regarding Rust in the area of medical visualization. We are, again, very happy to have them. It's always interesting and exciting to see when Austrian companies in an innovative area are using Rust more and more, and therefore we are glad that they take the time and will be with us on May 27th. That will be our next meetup. And that's it. That was my community news area. And with that, I take a look at the clock. It's 5:40, so we are nearly in time. We have a little bit more, a few minutes to set up. And I will ask Jan-Erik on the stage. So let's see if Jan-Erik is already here. Jan-Erik, are you here and can you hear me?
Yes. Hello.
Awesome. Thank you for being here. Jan-Erik, I always ask our guest speakers the same question. Where are you from? We had guest speakers from all around the world. So where are you broadcasting from?
I am in Berlin right now.
In Berlin, just like Ryan. We had Ryan as a guest speaker. Okay, I see. So you two know each other pretty well, I guess?
Yeah, of course I do.
Yeah. Awesome, awesome, very good. Jan-Erik, you can share the screen with us if you want, and I will get your slides on the screen just to make sure that everything works properly.
There we go.
That looks very good. Jan-Erik, again, thank you for being with us. The stage will be yours in a second. Is it okay if I relay questions from the Discord server to you at the end of the presentation?
Yes, let's do them at the end.
Awesome. Let's do them at the end. So we will do questions at the end. And with that, thank you. And the stage is yours.
Thank you. It's still weird speaking to your own computer and not seeing anyone. So welcome, everybody. I'm very happy to be here. And I'm here to talk about how my team at Mozilla is using Rust to build cross-platform mobile libraries. Or more precisely, actually, libraries, because we're targeting desktop as well. I gave a similar talk by the same name last year at Rusty Days, but I modified the content, so there's going to be new stuff even if you listen to the last talk. So first, a little bit about me. I'm a Firefox telemetry engineer at Mozilla, and I'm going to talk more about what that actually means. And I'm also a Rust community member. And beyond that, I do organize the Rust Berlin Meetup and also a RustFest, the European Rust Conference. And when I'm not at the computer, I'm actually trying to do more scuba diving. You'll find me online on Twitter or my blog, and you will also find the slides under that link. It will contain all the additional links and material that I'm using. So I'm here today to talk about Rust and how we use Rust at Mozilla. And more precisely, I'm going to talk about Glean, the library I've been working on for more than 2 years now. Glean is a telemetry library that's now used in our products as the data collection library to give us data about how our products are used, which features work, and how the performance is. So why do we do this? We are building a web browser, and building a web browser means we need to make sure that the whole web works with it. And it's impossible to test the whole web by ourselves. So we, to a certain extent, we rely on getting some data about how the browser is used out there in the wild by all our users actually giving us that data with their consent. So what is this data? We try to instrument the browser to get different data points about the feature usage and how they perform out in the wild. Here on the screen, you see one of these data points, which we call metrics. And that's the metric which measures the time spent running the JavaScript garbage collector. So if you're using the browser throughout the day, whenever you visit a website that runs JavaScript, at some point the garbage collector will kick in and clean up memory. And then we measure how long that takes. And then locally, we aggregate that data. And once or twice a day, that data is sent to us. Our servers will then take all the data we get from all our users, aggregate that again, and store that in a way we can later analyze. And here is one of the things we generate out of that data, a graph that shows the distribution of the time spent running this garbage collector. This data is actually publicly visible on telemetrymozilla.org. And what you can see here is a pretty standard distribution of runtime for the garbage collector. And for the average person, the garbage collector probably takes around 60 milliseconds. So whenever our engineers touch the JavaScript engine, they don't have to only rely on their own local measurements on their own fixed hardware, but they can look at the data we get from all of you out there that are using Firefox and see whether the changes they made have any impact for better or for worse. We can then use this data to optimize and improve our browser the way it works the best for users. And when we do collect data, we do this under what we call the lean data practices. The lean data practices are essentially 3 principles. The first one is staying lean. Whenever we do want to collect data, we are very conscious about the questions we want to answer using this data. And we state the questions up front, and most of the time we actually upfront limit for how long we want to collect this data. By just not having the data, we might not be able to answer questions, but we also don't need to worry about how to handle the data after all. The second principle is building security. As I said, not having the data is obviously the best part, but we still want some of the data to make decisions. So we are very, very conscious about not collecting user data, but focusing on the technical data of how features are used and how the browser performs. And again, this is written out before we even measure any of this data. And it's also because it's all open source, you can actually check that out. And the third principle is engaging our users. We want users to understand why we collect this data and how this data collection benefits the product and how they can use the product after all. And also, people are always free to enable or disable this data collection. And last but not least, we do make some of this data public. We are very careful about how we do this. So in general, you get aggregated data as you saw before. If you really want to know more about how we do this data collection, especially at the scale that Firefox works at, check out a talk by my colleague Jan about collecting data responsible and at scale. So now let's get into the library that I'm working on, Glean. The Glean SDK is a modern approach for a telemetry library. And we have what's called the bigger Glean project that incorporates everything from the SDK used in client applications to a pipeline and analysis tools that we use. About a bit more than 2 years ago, inside Mozilla, the development of a new version of the Firefox for Android browser started. Back then, we did have telemetry and data collection inside the desktop browser, and to a certain extent had that in the old version for Android as well. But we knew about issues with using that. We knew that it was not the most convenient for our engineers to add new data collection or data points. And it was certainly not made for a modern mobile application. So the new development of Firefox for Android, we took as a fresh start to also redesign how we collect telemetry data. So we were presented with a blank slate and could fix all the issues we know that we don't want to do again. So what did we know back then? We definitely knew who's going to use our library. First of all, obviously, it was Firefox for Android. That was the main target, especially more than 2 years ago, because that's what we were focusing on. But we also had a team on standby that was developing the iOS browser that also wanted to incorporate better telemetry into their product. But the existing telemetry library was more thrown together than coherently designed. So we knew we needed to support them too. And obviously, because we already have such a huge data collection library inside the desktop browser, where we learned all these things that we don't want to repeat, we knew eventually we wanted to replace this. So by now, we already have 3 platforms that we need to target. But what's actually used there? How are they programmed? Well, on Android, it's mostly Kotlin. That's what you by now use to write any Android application. So you need to support an API in Kotlin. On iOS, you obviously have to use Swift to do anything useful, really. And on desktop, it's actually a mix of C++, JavaScript, and Rust. So these are all 3 languages that we also need to support. So to us, it was very clear cross-platform support is a must. We were a very small team of back then only 4 people that had to work on this and had to maintain it long-term. So re-implementing the same design of a library in multiple different languages was just not feasible. So we decided to build this on top of Rust. So let's jump into how the SDK actually looks. The Glean SDK is split into several layers, each doing their part to build the full SDK. On the very low bottom layer, we have the Glean Core crate written in Rust, which builds all the functionality that Glean actually provides. On top of that, we have the FFI library, which is the binding between the low-level Rust code and the higher-level Kotlin or Swift code that is used later in the applications. So let's look at the Glean Core crate first. The Glean Core crate is really just a simple plain old Rust crate. It has like a struct that holds most of the state. It has implementations on this struct that contains the main logic, including storing and reading data from the database, preparing things for upload, tracking the metrics, and especially also tracking how it behaves internally, and then offering the API to the outside to use this whole thing. Additionally, we have implementation of all the metric types that are used, also written in Rust. Metric types can be as simple as a count or as a string, but can be even more complex, like the timing distributions, as you saw for the JavaScript garbage collector before. So that's all handled within a single Rust crate. And there, the benefit of using Rust already pays off. Because it's all written in Rust, we can use everything that's available in the Rust ecosystem. We can rely on external crates. We can rely on the tooling that is available for Rust. And testing is also super easy and super quick. And additionally, we already support all the major platforms right from the get-go, which we can compile to. But obviously, that's only half the story. So let's jump upwards in the stack and look at the Glean FFI crate. The FFI crate is the connection between Kotlin, Swift, or other implementations to the lower level Rust crate. Now, most other languages can't really talk directly to Rust code, but most other languages can talk to C code. So by providing this FFI layer, we translate Rust into C, which can later get called. So what does FFI stand for? FFI stands for Foreign Function Interface. And it's really more or less just a deterministic and simple naming of symbols such as the functions that you can call. And additionally, it is a stable ABI, that's the application binary interface, which describes the memory layout of the data and how you call functions and pass data into these functions and get them out. Writing a FFI layer or a C-compatible layer in Rust is actually surprisingly easy. To be callable from other languages that know Rust, that know C, you have to write a bit of plain Rust code and extend that with a couple of attributes to make it possible. Here you see a function called hello Rust Linz that is actual Rust code, and that has several additional attributes. First off, you see no mangle. No mangle signals to the compiler to take the function name as is and put it in the binary so any caller can find it by that name later. If you don't do this, the compiler will actually change the name and encode a bit more information into the name, but make it unpredictable what it is, and therefore you can't call it. The next attribute you see is the extern C. This specifies the ABI that is used when this function is called. So how data gets passed in, whether that's on the stack or in registers, and how data gets passed back out, and who's responsible for managing certain parts of the stack and registers. Now, the C ABI or C itself is much more restricted in what it can express, and is especially more restricted than Rust. It doesn't have the expressive types that we have in Rust. It doesn't have generics, and it doesn't know references. And this shows you will always need a translation between actual Rust types and the types as they would look in C to pass data around. And one thing you already see on this slide here is strings look vastly different in C-land than they do in Rust-land. Strings in C-land are really just a pointer to a byte buffer somewhere that's ended with a null byte. That's completely different from how it looks in Rust. Luckily, Rust makes it easy to work with strings that are coming from C or need to be returned to C. There's C string in the standard library. C string just takes your regular Rust string, appends a null byte, and then gives you access to the underlying buffer or even a pointer to this buffer so you can pass it back to C. There are more of these things in the standard library available that help with some of these abstractions needed to talk to C or get called from C. Now, one thing if you want to get called from C is that C needs to know what functions are available and how to call them. So usually you have the definitions of your functions in a header file that you include. So at compile time, the compiler knows what to expect, and the linker will later link to your library, which has the actual implementation. But writing out this whole header file is a bit tedious, especially if you're writing a full library. You don't want to do this for every of your functions. Luckily for us, there's a tool out there, cbindgen. Cbindgen takes a Rust code, parses it, and then generates the appropriate C header file. So consider the code on the left, our hello Rust Linz function again marked with no mangle in extern C and returning a pointer to some arbitrary data. If you pass that to cbindgen, you get a header file that looks like the one on the right. You got a C definition of the same data, of the same function, with the appropriate C types. Now, if we take this and throw this against our library, we get a large file that contains everything we need to make this callable from anything that knows how to call C. Luckily, on top of that, we make extensive use of the abstraction functionalities that Rust has to offer. And one of these things we use is FFI support, a library that essentially bundles a lot of the patterns we use throughout our code base. It was started by another team at Mozilla, the application services team, that do a very similar thing of writing cross-platform libraries. And they come up with some nice patterns that make it easy to write FFI code that looks mostly like Rust, but under the hood does all the necessary stuff to be callable from C. One of these nice abstractions we use is the into FFI trait. Into FFI generalizes about type conversions between Rust types and FFI compatible types. I already talked about strings and how different they are and how there are certain abstractions in the Rust standard library, but passing strings back to C is still a mostly manual process. By using into FFI, we can write this process once and define the behavior we actually want. And then in our code, we only need to use this trait and call into this trait instead of repeating using C string manually all the time. Another nice abstraction that we use is FFI string. So far, we've been passing strings back, but we can also take strings from the C side into the Rust side. But as said before, strings are really just pointers. And pointers in Rust don't have any lifetime attached. So you need to be very careful how you handle them. You can't really store them, and you definitely can't turn them into reference to then store them, because the data behind this might be gone by the time your function ends. So you will always need to clone the data and then turn that into a Rust type and make sure to use it that way. But nothing in the pointer really helps you with that. FFI string changes that. FFI string essentially is a wrapper around such a string pointer and makes sure that it will have a lifetime when you take this as a parameter on your function, and also restricts how it can later be used. It will only allow you to get a reference for the short time that your function runs, or get an actual own string that you can store somewhere else by copying the data out. The nice thing about these two abstractions that I showed you right now is that they are really just zero-cost abstractions. They compile down to the exact same code as if we've written this all manually. But we can rely on the compiler to do the right thing if we've written the right code once. So let's look at compile targets next. Most people write, compile, and run their Rust code on their own machine. Sometimes, obviously, they need to run it elsewhere. And that's when you need to reach for the compiler to actually compile for that other target. Think about compiling on your Mac and running on a Linux machine. Luckily, the Rust compiler is a cross compiler by default. The Rust compiler knows how to take Rust code and turn that into some other machine's machine code. That only applies to Rust code, though. And there is a bit more to actually get final working libraries or binaries. So if you installed Rust through RustUp, then you can ask RustUp for a list of all these targets that Rust knows. And it will show you a long list and it will tell you which ones it has installed. And by installed, here it really just means it downloaded a compiled artifact for the standard library, so you don't have to recompile that every time. So you might look at this and think, well, what is this? What are these characters? What does it even mean for something to be ARG or x86 and then unknown? So what is a target? Well, a target is roughly the combination of the computer architecture, the operating system, and the ABI you want. Though sometimes the ABI is actually the libc you link against, and sometimes the target is a triple, but has like 3 to 5 components, depending on who you ask. And yes, I'm now totally ignoring any off by 1 or more errors here. And as I've recently learned, some components of this triple can actually contain version numbers, which down the line in your tools decide which other tools to call. It's quite a mess sometimes. The Glean SDK is currently compiled for 11 targets. We have several targets for Android here. We then have targets for all the major desktop operating systems, either for testing or even for shipping our Python bindings. And then we have the iOS targets. Adding them using Rust up gets you mostly there to compile your Rust code. It can compile the Rust code, but that doesn't really mean you get a successful build out of that. Rust doesn't know anything about the target-specific linkers or libraries, so most likely you will need a few additional tools to get final working libraries. For Android, that's the Android SDK and NDK, easy to get by. For iOS, that's a Mac and Xcode, which will bring the SDK and tools that you need. So now let's wrap up the FFI layer and look one further up. Let's look at our Glean Kotlin implementation. We're only focusing on this here, but the other implementations are actually mostly similar. So how do you make Kotlin talk with the C API? We use a library, a Java library called JNA. JNA provides Java programs easy access to native shared libraries without writing anything but Java code. No JNI, which is another library, or native code is required. When you read Java here, think about the JVM. It works the same with Kotlin, which is what we use. Let's quickly jump into a small hello world and how this looks with JNA. Again, we have a Rust function with our additional annotations, no mangle and x.c, and we return some pointer to some string data. That's our Rust code. On the Kotlin side, we use JNA and describe our interface. Then we tell JNA how to load this using native load and giving it the name of the shared library. Further down, we list all the definitions of the functions that are available. I spoke about cbindgen before, which generates C headers. Unfortunately, Kotlin and JNA are not able to read these. So here we need to manually list out the FFI functions with their Kotlin equivalents or JNA equivalents manually. It's a bit bothersome to do this, but it's only for one of our bindings. So we did it once, and it's not perfect, but we just didn't invest time to build tooling around that. If you have done this, you get an instance of a class in Kotlin or Java on which you can just call these methods as if they were native Kotlin methods. And that's really just it. To compile this, you're going to rely on Gradle, the build system that is used throughout the Kotlin and Android ecosystem. You can use the Rust Android Gradle plugin, which takes care of compiling stuff for you. It gives you a configuration block where you configure which cargo project to build, where it is, by what name what name the library will have when it's compiled, and the targets you should compile for. Now, whenever you build your Android project, Gradle will also build your cargo project and make sure to place the final dynamic libraries in a folder so your test code or your application will later find them. And that's basically all there is to it. We do a lot more stuff on the Kotlin side to then build the nice Kotlin API, but internally, we're just calling any of these functions on the API, on the FFI layer. And we do this for several other Glean implementations as well. As said before, we do have a Swift implementation, and there it's slightly easier because Swift speaks C, so we can use the C header we generated using cbindgen more easily. We also have a Python implementation, which works similar to Swift. Using CFFI, again, we can parse the C header, which internally generates Python code that gets called, and then we have a bit of Python code that provides the nicer API to users of the SDK. Next, we have a C++ implementation, which is used in Firefox Desktop. It works slightly different because of the setup of how desktop works and how it interacts with Glean, but conceptually, it's very similar. It calls some FFI that calls into the Glean Core crate. Everything is compiled together, so everything just works. And lately, we also have a JavaScript implementation for desktop. Now, this is actually also written in C++. It's one of the benefits of being the browser that has the JavaScript engine. You can write your JavaScript code in C++. But don't worry, this is not directly accessible to any websites. It's only for the JavaScript that actually builds the browser itself. We do now have another project, essentially a re-implementation of the Glean SDK called Glean.js, though. Glean.js targets websites, web extensions, and even node environments, so you can use that there as well if you can't rely on the Glean native library. And last but not least, we do have a Rust implementation. Now, what I didn't really show is that the Glean Core implementation is very low level. It's just enough to provide everything to the FFI layer, but doesn't provide the nice API that we want our users to see. So we have another implementation of Glean on top of the Glean Core crate, also written in Rust, that has a much nicer API to use. But you see from this list, there's a lot of things we need to target. And whenever we change something in the Glean Core crate, we also have to re-implement that up the stack. Whenever we add a new metric type inside the core crate, we need to add functions to the FFI layer to use this metric type, and then build a nice API in Kotlin, in Swift, in Python, and the other languages, just to make it usable across all the implementations. And that's still a lot of code. It's not a lot of logic, so it's more like copy and paste that we do, but that's still not nice to maintain. So what if we don't need to write that much code? I always think about that. And luckily, others at Mozilla also think about this and actually find the time to do something about this. So some other good folks at Mozilla came up with UniFFI. UniFFI is a multi-language bindings generator that essentially everything that I just told you does under the hood, and the only thing you write is Rust. So let's look at this quite quickly before we end. Using UniFFI, you define what your interface should look like in a WebIDL-like definition language. WebIDL is used to describe, for example, the JavaScript interfaces as they are exposed to websites, and it's extensively used in both Firefox and also Chrome. And we can now use this to describe the interface we want from our cross-platform libraries. So here we define an interface for a rocket. A rocket can be constructed with a name. It can then later be launched. And because a launch can obviously fail, we can throw a launch error. We now take this definition and implement it in Rust. And this is, again, pure Rust implementation. We have a struct that holds some state about the rocket, and then an implementation of the rocket. By convention, the constructor becomes the function new, and other functions on the interface become normal methods on this struct. And throwing in our interface turns into a result type on the Rust API. Other languages that use this later might see this as an exception or the equivalent to a result type. Now equipped with the Rust implementation in our definition, we throw this against UniFFI, and some magic happens. And when that magic finishes, you can use this in Swift, in Kotlin, and in Python just as easily. And we didn't write a single line of Kotlin, Swift, or Python to make this all work. UniFFI did that for us. All we did is use a nice API that feels very ergonomic in the language we're writing it in. And under the hood, it does all the right things to call into Rust code and actually run. So what's this UniFFI magic? The very first thing, obviously, is the FFI layer. In Glean, currently, that's a whole crate that's doing this. In UniFFI, this is just generated for you and does the right thing all the time. The next thing UniFFI takes care of is the conversion between all the types. Again, you need to convert the Rust types into something you can pass over a C layer, and then later need to turn that into something the target language understands. And UniFFI knows that in both directions. So whether you return a string from Rust and use it in Kotlin, or generate a string in Kotlin and pass it into Rust, UniFFI will take care of allocating the right amount of memory to put data in, pass it around, and later deallocate it, all safely. And then it also provides the convenient APIs for the target language. So it generates code that actually feels very ergonomic in the language you target, like Python, Kotlin, or Swift. So how does this look like under the hood? Well, this looks actually more or less the same as what I just described to you in all the other slides. You again have some functions which have our now known attributes nomangle and extern C. And if you look into the actual last line of code, you see the call to rocket new, which is just a call to the actual implementation of our rocket that we wrote ourselves. And then it does a bunch of other stuff and has some weird naming. On the other side of the FFI, you have the Swift code, where it just implements a Swift class, and the constructor of that Swift class knows which FFI function to call and how to pass data in. It also adds all the other functions and also knows how to call the right FFI functions for that and how to pass data in there. And that leaves you with writing none of this at all. Now, we wrote code exactly like that before, and I give it to you like we used a bit more human readable names where UniFFI mangles these names again, but UniFFI keeps track of it. So why let us write that code? Computers are much better at it. So last thing you might ask is, so why did Glean do all this stuff? Well, UniFFI only exists because we did all that stuff manually first. And now that we have more than 2 teams doing this, it was clear we can't continue writing all this manually, and we need a tool doing this for us. So when do we get this for Glean? Well, whenever I find the time, but hopefully by the summer, we will start moving over Glean to UniFFI instead of maintaining all that code. Thanks a lot to the Glean team at Mozilla, my colleagues Alessio, Bea, Chris, Travis, and Mike, who helped maintain this project with me, and also to the application services and UniFFI team, who we are in constant exchange with because we're still tackling the same problems together. On the slides, you find links to some of the resources. Glean and all the work we do is all public and open source, so you find it there. And now, if you have questions, now would be the time to ask. Thank you.
Thank you very much for this super interesting talk. For now, I will move the slides away. And yeah, it was very interesting. And first, let me say thank you for taking the time and presenting to us. I see people are currently typing in Discord, so maybe I can start with one that came up to my mind when I was listening to your talk. You talked about how Kotlin and Swift can call into Rust to do something there. Do you have use cases or the necessity to somehow call from Rust into, for instance, the Android operating system, into Java or things like that? Is that also a use case, or is that something that is not relevant for your project?
So in my project directly, it is not necessary because the way our telemetry is set up, it's pretty much a one-way thing where you pass in the data that we record and never need to ask for it back because everything else is handled internally. So we don't need to support that, which takes a lot of work away from me because I don't have to think about this. But obviously, like other parts and the other library, to a certain extent, they need to do this. So there are ways to do that. For Java, there are ways to call back into, or for the JVM, there are ways to call back into that part. It's not as streamlined as the other way around currently, but it is not impossible. For Swift, I don't actually fully know, but you can also like do essentially the same as you would do with Rust, where you have like the FFI-like abstraction on the Swift side, which gets callable from the other side. And then we have some work that actually allows to do some form of callback mechanism. So you can actually register callbacks that get called in one or the other direction. Though that has few more problems because of how memory allocation works and whether you need to be very careful with the garbage collector and stuff like that.
Okay, thank you for this answer. Now we have a question. Oh, this is the wrong one. This one. We have a question from Bram. It was coming in through the Discord server. How does Unify deal with cleaning up resources from garbage collected languages? He was asking whether it does it the same way that wasn't bind gen does it. So the calling language has to explicitly drop, or anything you can elaborate on that?
Yes. So that is actually the nice thing that UniFFI takes away from us. So right now, the way this is, for example, handled in Kotlin and in Swift is that you need to explicitly use some constructs to allocate data on that site. That's mostly unsafe, actually. They have similar concepts that as Rust. So you allocate data there and then pass in the buffer into the Rust site or through the FFI into the Rust site. And Rust can fill that data. And then the Kotlin or Swift are later responsible for cleaning up that data. In Swift, that has like unsafe APIs that do this for you, which basically work around their garbage collector. So you need to be explicit about the allocation and deallocation there. On the Java side, it works essentially the same. It also makes this very explicit. In the current Glean code, we need to do that all manually, and we have these allocation calls. So our Kotlin code actually looks very C-like because it needs to do that stuff. We try to hide that behind some abstractions, especially like for strings where we do this. But that's essentially what UniFFI does behind the scenes. So whenever it calls and needs to pass in data, then it will allocate, put the data in, pass that over, and later make sure that before it returns to you, the data is deallocated.
Okay, awesome. Thank you very much. Thank you very much. I have one question from my side. When looking at your talk and seeing how you use the web IDL to specify interfaces, I was thinking about how I currently work with Rust and wasn't bind gen and wasn't pack and so on, and became aware that it is kind of a little bit different, but also a little bit similar. Do you see any relationships between these two projects? So the C bind gen and the wasn't bind gen and the wasn't pack and the web IDL use in your project?
Yes. UniFFI was very much inspired by the work that wasn't bind gen does. UniFFI also takes a lot of inspiration from some of the interface type proposals for WebAssembly itself, which specifies how you encode certain data so you can pass it over a much more restricted memory buffer part. The reason we do, or UniFFI wants you to use the IDL, is that this allows you to specify your interface up front, and we can generate the same interface on both sides. So the interface that you describe is also what you need to implement in Rust, which makes the Rust thing directly usable as a Rust crate without the needs another crate on top as we currently do in Glean. But it also allows you to create the C++ code and the Python code and the Kotlin code that will look like actual Python code, which just internally does all that stuff. So there's definitely some inspiration there. And yeah, the using of the interface definition is is definitely one of the big separations between these two things.
Very interesting thoughts, and it's interesting to hear how these projects inspired each other. Jan-Erik, let me share some things at the end. You see, we have really great feedback coming in. Here we have one, and here we have one, and many other things are going on at Discord. Thank you very much for being here. If you want, you're always invited to stay a little bit longer on the Discord server, ask or answer questions there or whatever. And whenever you have something interesting you would like to share with us, you're always welcome as a speaker at the Rust Linz Meetup. So thank you, Jan-Erik, for taking the time, and thank you for coming, at least virtually, from Berlin to Linz today.
Thank you for having me. It was fun, and thanks everyone for listening. And yeah, I'm going to stick around in the Discord channel, so if there's any more questions, just hit me up.
Thank you very much. Thank you very much, Jan-Erik. Okay, and with that, we have 10 minutes to go until we start with Herbert, and we have a raffle going on today. I told you already, let me share my screen. Let me rearrange my stuff a little bit. So I share the screen and share this one, and put that on the screen here. Let's put it that way. And I told you that there is this Entwickler Kiosk Rust Day next week on April the 28th. And there will be exciting talks throughout the day, as you can see here. And now we have 2 free tickets to give away for this day of Rust. And how do we do that? Well, we have our friend Stefan Baumgartner, who is also very active in the Rust community, and a big shout out to Stefan, because without him, he helped a lot organizing this Rust Day too. And he is known as the Internet Batman. And one of his trademarks is the kind of the way he does raffles at his community events, and he borrowed his Batman, his Internet Batman raffle logic, and I took it, translated a little bit into Rust, so it's a kind of community work between Stefan and I. It works like this. Here you have a gray area, and when I click on this area, the Internet Batman will enter the stage, and it will walk through the people who registered for today's meetup here at the Meetup Linz. And in just a few seconds, we will see a name on the screen. And if the person sees his or her name and wants to have the ticket, I ask you to send me either a direct message on Discord, or send a quick note in the YouTube chat, or send a message into the Discord chat so that we know you are here, and then the ticket is yours. I will always wait for a few seconds until we see if the person is present, and the first 2 people who registered for the Linz meetup who are present will get the tickets. Okay, are you ready? So let's go and let's call the Internet Batman in. I am not sure if you hear my sound, but you have the classical Batman sound here. Unfortunately, I didn't test it, whether this is broadcasted too, and here we have that. Karsten, we got the result from calling into Rust. Let's see if Karsten is here, and if Karsten would like to have the ticket. So Karsten, if you are here, please give me a quick note, either on Discord or through the YouTube chat. I'll wait for another 5, 4, 3, 2, 1 seconds. And with that, if Karsten will come around in the next few moments, we will give him the tickets anyway, because we have 2. But now let's call in the Batman again and wait for a few seconds. Let's call into Rust, and bam, we have a winner. Kafiraje. I'm not sure if I spelled the name correctly. By the way, the whole day is virtual, so you don't need to travel to Germany. And the the sessions, if you take a look, are to a large degree English. So only one is German. So if you are an English speaker, that would be fine. Do we have the second winner here? And does the second winner would like to have the ticket? We still have 5 minutes to go, so we can try that a few times. And we will wait another 5, 4, 3, 2, 1. Raffle again. In a few seconds, we will see bam, pow. Glenn. Is Glenn here and wants to have the tickets? I will give us 3 more tries, and if we are unlucky and we draw exactly those people who aren't here, I will maybe come up with a different way of giving away the tickets. Glenn, are you here and do you want to have the tickets? We'll wait for another 5, 4, 3, 2, 1. Let's try it again. Nguyen, are you here? And would you like to have the ticket? If yes, let us know through any kind of channel, either Discord or YouTube. So the internet Batman wasn't successful by now. Typically, typically in a real world setup, we ask people to write their names on a piece of paper, and then we can draw from all these papers. But hey, we are here in a virtual scenario. I think we have to, Stefan, we have to work on Batman so that it fits better to online meetings. Last one, and afterwards, I will just ask some questions and see whether we have one. Cosmin, is Cosmin here? And would like to have the tickets. Let's see. Five, 4, 3, 2, 1. Okay, so we will do it differently. Let's just ask 1 or 2 questions that we had in the last talk. Maybe, Jan-Erik presented an interface definition language that had a certain name with which you can define interfaces that the UniFFI module can turn into Rust code and, for instance, Java code and so on. What was the name of this interface definition language that the UniFFI project uses? The first one who answers this question through YouTube or the chat will get the first ticket. WebIDL, not Matthias is the first one. Not Matthias, the first ticket belongs to you. We know each other, and you can send me a direct message or I will send you a direct message. You are a regular user regular visitor here of our meetup. So we are friends on Discord and I can send you the invite code. Okay. The second one, no, Carl, it's not like in school. It will be a very simple one. The question is, are you fast enough? Okay. So the next question that I have for you. For WASM, the macro is called WASM bindgen. How is this bindgen thing called for C interrupt for Rust? Not wasn't bindgen, but who wants to have the ticket? Not wasn't bindgen, but I'll see people typing Seabind Jan. We have a second winner. Very good. So we finally have 2 people who are hopefully happy about the 2 free tickets. And for the second winner, I will send you the invite code also through Discord. So stay tuned. I will do that during the next talk. And with that, we are perfectly in time. It's 6:30 p.m. and I can ask Herbert to enter the stage. Hi, Herbert. Are you there?
Hello.
Hi, Herbert. We are really glad to have you here. I always ask the speakers from around the world the same question, so I have to ask you too. Where are you broadcasting from?
Right now, I'm in Columbia, Missouri, which is, if you drew a cross right across the continental United States, it's pretty much the exact middle. I'm actually from London, England originally, but I've lived over here for 20 years, got married, settled down. If you hear any weird noises, there is a golden retriever behind me who really wants to join in. So.
Okay, we are happy to have him. So if he wants to join in and has something interesting to say about Rust, he's always welcome. No, just kidding. Herbert, thank you very much for being our guest and taking the time. For us, it's late in the evening, and for you?
Right now it is 11:30. So it's coming up on lunch after this.
Okay. Awesome. Very good. Herbert, you have an exciting topic, and I see you already share your slides with us. Rust game development. We are all looking forward to your presentation. I would say the stage is yours. I will leave the stage whenever you need me. Just tell me. I will be here, and we are all looking forward to your talk.
Sounds good. Thank you. So welcome to my talk on 2 topics I'm very passionate about, Rust, the language, and game development in general. I'm Herbert Wolverson, and I'm going to cover 3 main topic areas today. Who am I? So, who is Herbert? How did I get into Rust? How did I get into game development? And hopefully why you should listen to me. Then we're going to look at making a game, Flappy Dragon. It's only a couple of 100 lines of Rust code. It's pretty straightforward, and it's a good example of how Rust can be very productive for making a game. And then we're going to look at the Rust game development ecosystem overall, looking at a few of the engines that are starting to come along, looking at the explosive growth in Rust use in the game industry, and then we'll open up for questions. First of all, like I said, I'm Herbert Wolverson. I use the pronouns he, him. I recently published a book in beta called Hands on Rust. The book is currently available in beta on PragProg. We'll talk a lot more about that in a moment. Before I did that, I put up a Rust roguelike tutorial. I'll be talking about that again. I'm in the process of publishing The Making of SecBot, which was a game I made for a Make a Game in 7-Day challenge. I'll be sure to include some links to that in the post about this presentation afterwards. Over the last decade or so, I've worked on Nox Futura, which is basically Minecraft in space. One Night in the Dungeon, which was an Unreal Engine roguelike. SecBot, which was the 7-Day challenge. Tech Support, the roguelike, which is a fun mini game I used to learn some modern C++. The idea was that you receive missions and have to avoid your managers or vendors because they depress you into quitting the industry. And Apocalypse Taxi, which is just a general procedural generation game I made for fun that just makes random cities and has you drive around being a taxi driver. So many, many years ago, many more years than I should admit for my age, my dad was working at a local community college and was teaching computer skills. And one day he brought home a BBC Micro Model B, which is the computer that's pictured there, I guess in mirrored on the right. It had BBC Basic built into it. And BBC Basic is a lot like regular BASIC. It just supports functions and procedures. It's a little closer to a modern Visual Basic. Now, I was at the tender age of 6 or 7 at the time, and it wasn't long before I was starting to get fed up with just the games that were on the intro tape. Yep, we loaded games from cassette back then into all 32K of RAM. So my dad started showing me BASIC. You can see on the right what's probably the first program most people write when they pick up a Boosie Micro. Hello World. And back then, the norm was that magazines came out. They were absolutely chock full of source code. You carefully copied the source code onto your screen, saved it, ran it, and usually nothing worked. So then you got a crash course in debugging. And this is actually a really good way to learn a language because you have to start picking up a bit of understanding of what's going on, even though it's often complicated and over your head. But after a while, you start figuring out, okay, I typed that wrong. And because you're looking at it, you start to get an understanding of, well, I see why this works. And then as I got older, it started turning into things like, well, this game would be more fun if I had more lives. So I'd find a bit of code that let me change that. And so this really got me started on a trajectory throughout my life so far, in which whenever I want to learn a new programming language, I do so by writing some simple games. And I really find that brings the fun into it. And I wanted to share some of that fun. So over the last decade or so, I was primarily writing games in C or C++ using GCC and Visual Studio. I actually got started out with text-based MUDs, the old ones where the console says, you are in a 10-foot by 10-foot room. There is a hole in the ground here. And if somebody else who's logged into the same system comes in, it'll tell you Herbert is here. And you might interact, you might not. But it's very simple text-based stuff, but an awful lot of fun. Then I started getting into tile-based games, Angband, NetHack, that sort of thing, and started working on bringing in graphics to those. Became completely addicted to Dwarf Fortress, which I still think is the best game ever. And Nox Futura is, I think, at some point in people's lives, everybody decides that they're going to make a Dwarf Fortress, and Nox Futura is my attempt at that. There's a pretty decent C++ version, and the Rust version is coming along. But then I got into One Night in the Dungeon, my first effort at trying to use the Unreal Engine. Oops. Sorry, didn't mean to skip yet. The Unreal is fantastic in that you can lay out your maps, write a lot of code, things work. And it's a real pain in that you allocate memory, do something with it, and Unreal actually has a garbage collector, but you're never quite sure when it's going to run. And you very quickly start tying yourself in knots with maybe this object exists, maybe it doesn't. And likewise, when you're threading, particularly when you're sending events in between actors, it gets pretty muddy as to which thread the event will fire on, what exactly will happen. And I started getting into fun problems that on my relative potato development computer, my game would run great. Give it to somebody running an absolute monster with tons of cores and lots of RAM, and things would randomly break. So I was finding that painful. And I'd been talking to quite a few people on various Discords, and I'd been hearing that all the cool kids were now starting to dabble with this language called Rust. So I wanted to know, is this going to help me? And from what they were saying, it sounded like it was going to be a really good fit. Because first of all, Rust won't let you do really stupid things with memory. And believe me, I was getting really good at doing stupid things with memory. And multi-threaded synchronization is Rust's other big strong point. I've seriously never used a language that made threading so easy, and that's just lovely. So the roguelike dev forum on Reddit was running a let's make a roguelike. They do this every summer. Typically, they provide a tutorial in Python using a library called libtcode. Well, I decided, okay, well, I know this much Python, and I've written this in C, so I'm going to follow along with the tutorial, but I'm going to concurrently try and write it in Rust, use it to learn Rust. And it was a little bit of a rocky start, but the program you can see running on the right side of the slide was the result. I made it all the way through the tutorial. I did prove the old adage that if you write C for long enough, then sooner or later you can write C in any language. I quickly started to realize, yes, this works. I like Rust. I need to go back and I need to create this in good Rust. Because I really wanted to provide some solid underpinnings, I created bracketlib. Bracketlib is a lot like libtcod, which is it's primarily a virtual console. It can compile to native GL, run in curses if you want to use it over SSH, compile into WebAssembly. It's relatively flexible. I actually made version 0.01 in a day, and most of that was spent figuring out OpenGL bindings. Over the next couple of years or so, it's gained just about everything from pathfinding to field of view. And it did this as I was working on the taking my 7-week learn Rust by making a roguelike and turning it into good Rust, which became the Rust roguelike tutorial that I've linked on the screen there. It started out as 8 chapters, and it's now up to 74, and I'm still not done. I'm really enjoying it, really enjoying the feedback I get, and I'm really excited to be able to open source everything, share it back with the community. The Rust community is just fantastic. I've seriously never worked with a group of people more willing to take the time to help you, more willing to read through your utterly broken code on GitHub, and instead of flaming you, send you friendly PRs that just tell you, hey, you can do this and save yourself 100 lines of code, or not do something dumb. And I've yet to encounter somebody who's angry or mean about it, and really that is one of the biggest draws of Rust for me, is having a friendly community that just wants to help really, really makes working with it on a daily basis so much easier. So as the tutorial grew, Erland Sogenhallen from the Amethyst Foundation got in touch with me. Amethyst was absorbing specs, one of the libraries that I was using in the tutorial. And because they were curating specs, and the tutorial spends a lot of time using it, they onboarded the Rust tutorial into the Amethyst Foundation. They were also talking to a company called the Pragmatic Publishers, PragProg, about getting a book about Rust game development. The publisher liked what they saw from the tutorial. After a few weeks, it was decided that I would create Hands-on Rust, which initially started that life known as Learn Rust by making a game. And that book is currently on it, winging its way to production. I'll give you some details about it in a minute. Now for this next section, we're going to be looking at a game called Flappy Bird. This is the third chapter in Hands-on Rust. Flappy Bird has very much become the hello world of game programming, and for quite a few reasons. First of all, it's a great way to try a new language. It's simple enough that even writing it low level, you're not going to need more than one file worth of code. A couple of 100 lines of Rust is enough to get you a relatively polished implementation. I personally think that Flappy Bird is a fun game, so I enjoy making it. I've made it in a few languages, and it's a great way, once you've written it in one language, it's great to implement it in another so that you can start to get a feel for how the different languages flow together, much like you go to the Hello World collection to get an idea of, hey, Rust is a really terse language, and, Perl is really readable when you haven't decided to be clever. Also, very importantly to me, Flappy Bird is very easy to prototype without graphics and then add the graphics in later. Now, I've seen way too many game development projects over the years fail because they come up with a great idea, and it usually is a good idea. They task the artists, they spend a really long time making everything beautiful, and then they play the game and discover, well, this is not fun. We have to make some pretty big changes. So whenever I start a project, I try to stick to very simple. If it's 3D, basic cube, sphere type things. If it's 2D, I pretty much usually start with ASCII or something hand-drawn in Microsoft Paint. That way you're keeping it simple. Once you've got a prototype that works, the game is fun. And once the game is fun, you can make it beautiful. It's a lot harder to go the other way around because your poor artists start to get really fed up with you on the 30-second time that you ask them to change everything. So when you look at Flappy Bird, what makes it up? Well, first of all, Flappy is a bird. Or in this case, I'm making Flappy Dragon, so he's a dragon. Nobody really knows why he likes flying east so much, but he's obviously on a mission of some kind. Now, Flappy Bird is great because there's only one control, flap, which adds upward velocity. You press the flap control, you flap upwards. Conversely, you've continually got gravity pulling you down towards the bottom. If you fall off the bottom of the screen, you're dead. There's also, because otherwise this would be a really simple game, obstacles appearing on the screen. You have to try and dodge the obstacles. If you hit them, once again, you're a dead bird. So, how would you go about building your very own Flappy Dragon in Rust? So when you do cargo new and create your project, you find yourself looking at Hello World. The problem with just starting typing and printing out your level is that games work a little differently from console programs. Your operating system is continually sending you a stream of events. It might be telling you the mouse moved over here, somebody moved the window, somebody resized the window, somebody closed the program even. Or, if they want to give you nightmare fuel, somebody dragged the window to between two monitors, each of which has a different display scaling. And under the hood, you find yourself having to worry about most of these. And that's why bracket lib simplifies things a little bit. Well, but instead of a typical console program, which blocks every time it's waiting for input, you want to keep running. So if you could do this purely in a console using threads, or using non-blocking I/O, and it starts to get messy and not very cross-platform. And it also starts to get stuttery when you start to build a really big game. So to support, so pretty much every game out there uses a game loop. Now, game loops typically start up by doing all of the interaction required with the operating system to actually get a window on the screen. In some cases, that can be a lot more work than you might think. For example, I've seen simple Vulkan or WGPU initialization wind up at 400 or 500 lines of code. And you need to make that cross-platform, not worry about it too much. So generally let the library do that for you. And then going into the loop, at the beginning of the loop, your library will be asking the operating system, so tell me what's going on, polling it for state. And you'll start getting notice that the cursor moved, keys were pressed. You might get notice that somebody wants to quit altogether. And if you're still going, then you call it. Then the library calls into your program's tick function, and tick is your interface with the universe. We'll be writing one in just a second. Tick typically runs 30 or more times a second because it's running every time the operating system is refreshing your screen. Most of the time, your tick function will check to see what state your program is in and render what needs to be done. It might also declare, well, you've called me too quickly, I'm not going to do anything. Call me back later, and that's fine. So when it comes out of the tick function, it's then up to the library to take whatever data it has that describes what you want to be on the screen and actually put it there. And again, you start getting into fun with making sure that this applies to the exact platform you're writing on. So for example, you might be talking to Vulkan, you might be talking to OpenGL or Metal, and ideally your library should abstract that away from you, and that's probably 3/4 of the code in bracket lib. So then it says, well, have we been told we need to quit? If you have, then it tears everything down, which again is more work than you might think. If it hasn't, then you go back to step 2 and you look for more information, and the game just keeps on looping through this until there's nothing else to do. So this is Hello Bracket Terminal implemented using bracket lib. We'll be going over the elements of this in a second, but just to give you an overview, at the top you've got the prelude, which imports all of the things that I thought were important enough that you might need them from bracket lib. State, which is a structure, we'll talk about that in a second, that defines everything your program needs to remember while it's running. Because every time it goes into tick, it's not going to have any other way to remember what its previous state was. Every call to tick is independent. Then there's the tick function itself, and at the very bottom we initialize the library. So let's start by taking a look at that. Here in the main function, we're using bterm builder to request an 80 by 50 text console. This is what's called the builder pattern, and you see it all the time in Rust. You typically start with a function that describes the basic outline of what you want. Then you call more and more with functions chained together like this. So in this case, we're specifying the window title should be Flappy Dragon. And then at the end of the builder pattern, there's usually a function called build or something similar that when you call it, combines all of the features that you described and pulls them together into some sort of overall description of what you want. I find it a much more friendly approach to writing configuration than either a giant INI file or typing or having to remember every single little setting in a giant list of 30, 40 parameters that you might wind up with if you wanted to include everything. The other thing to notice here is one of my favorite features of Rust. Main returns berr, which is how I describe errors within the bracket library. And you've got a little question mark right after build. So I could also write .expect and then a nice message saying failed to initialize. Or I could just unwrap it, and in the event of an error, it crashes completely. What the question mark does is it says, well, if this function returns an error and I encounter an error, I'll simply bail out and the Rust runtime will display the error. Or if you wanted to, you can be calling this from inside other functions, catch them, and try and handle it. And then we've got the context. We made the state object. So we call into main loop, and we pass it state, which currently doesn't have any data in it. Now, structures are just like objects in other languages. They're a way of combining data together to store it together. In this case, for Hello World, we really don't have anything that we need to remember from the previous frame. So we implement GameState, which is a trait. A trait is basically an interface. When bracket lib requires that you implement GameState for your main program. GameState in order to function, GameState requires that you have a tick. The nmut self, I always thought was a little ugly, but it means it can see the contents of that instance of state. And CTX context is just a link to the terminal itself, gives you various commands. In this case, it clears the screen with CLS, and it prints hello bracket terminal on the screen. Now, the nice thing about doing it with traits like that is that bracket lib doesn't have to know anything about how your program works. It just guarantees that as long as you follow the contract of communicating with the library through this interface, your program will work. And as long as I don't break the interface, I can update bracket lib and your program will continue to work. All right, so next up, now that we've looked at the basic what goes into Flappy Dragon and we've looked at how to get Hello World onto the screen, we're going to look at the general control flow that defines what Flappy Bird looks like. It's actually got one of the most simple general flows you'll find, very common one. When you launch the program, it shows you a menu asking you, would you like to play the game or quit? If you choose to play, then obviously the game runs. Sooner or later, it's inevitable, the player will die. Just like taxes, you can't avoid gravity and obstacles forever. When that happens, you go to a screen that tells you game over, hopefully tells you your score, and you have the option of playing again or of bailing out and quitting. So it's relatively simple. Now, I love Rust enumerations. They are very detailed. You can extend them massively. This is a really simple one, but I find that it really does a great job of expressing the intent of what I'm trying to describe. So we've got an enum called game mode, and you're either in the main menu, you're playing the game, or you're finishing. And then in state, we add a variable, and this just stores which mode we're currently using. And because enums can also have implemented functions, which I find, because GameState can also have implemented functions in addition to that required by the trait, I went ahead and created a function called new that returns a state. These are typically called constructors. Rust isn't very strict about what you name your constructors, you typically see them with names like new or default. And what the new function does there is it just sets the mode to be we're looking at the menu. We also made a function called restart. All this does is it tells it we're going to start the game or restart the game if you've previously died, and we're going to set the game mode to playing. Also made a function to display a main menu. This is very straightforward if you saw Hello World. Context CLS clears the screen. Then it prints welcome to Flappy Dragon. Press P to play the game, Q to quit the game. Now, if let is probably my least favorite named piece of syntax. It's really the same thing as match, but just for one case. And what it's really doing here is it's telling you there's a variable in context called key, which is an option. It's either none, meaning no key is pressed, or it's some and contains a key code telling you what key was pressed. So what that does, if let some key equals context key, which is a real mouthful, it's saying if context key matches the pattern of some, then take the variable key from inside it and make it available inside this block. And then we call match, which is like switch or case in other languages. And if it matches P, then we restart the game. If it matches Q, we tell context we're quitting. Otherwise, the underbar means everything else, and Rust will not let you skip options, so you end up with a lot of everything else because you don't want to write lines of code for every possible character on the keyboard. Then do nothing. This extends the tick function. So now we've got the game mode. We know if it's the menu, we should call the main menu. If it's game over, you should call dead. If you're playing the game, then you call play. Now I've actually created stubs for dead. Dead looks just like the main menu, except instead of saying welcome to the game, it says you are dead. And play is one line of code that simply says that you are dead. Well, it's common to stub things out like this, get the basic structure of your program put together. And it does, and then we've extended the initialization there to, instead of calling state with curly brackets, it calls the constructor. And on the right, you can see the entire game flow of the game we have right now. The menu comes up, you press P to play, you instantly die, you are dead, P to play again. All right, so that isn't a whole lot of fun. Menu quest is probably not everybody's favorite, so let's go ahead and start getting the character into the game. Now, once again, we're going to use a structure to describe the player. Structs really are ubiquitous in Rust. Between structures and traits, pretty much everything in the Rust standard library can be built. So don't be afraid of throwing structs at problems. Now, when you look at the player, they have an X location. Now, what in this case, the bird's staying stationary. So X is describing how the bird is moving through the world, and we're actually moving the world around the bird. So that way, obstacles will get closer, and we'll see a good example of that in a second. Now, the Y coordinate, just like a graph, is telling you the current vertical position of the bird. And velocity, which you'll notice is a float, is so you can put decimal numbers in instead of having to just use whole numbers, is telling you the current vertical movement trajectory of the bird. And this is kept independent from Y because velocity is cumulative. So as gravity affects you, you start falling faster. When you flap, you start moving upwards. And these can add together to give you relatively smooth movement. A new function also, this is attached to the player, called render. It simply sets one character on the terminal to a yellow and black @ symbol. I picked the @ because in a lot of ASCII games, @ is traditionally the player. I could have picked a D for dragon, or really anything else. At this point, we're prototyping. It doesn't matter what it looks like as long as you know what it is that you're looking at. And I decided to combine gravity and movement into one function because they naturally go together. So we start off by saying if our current velocity is less than 2, then we add 0.2 to it. Now, there's no magic in those numbers, i.e., as with a lot of game development, I started with other numbers. I kept changing them until I found one that I felt felt about right. It's certainly not an accurate representation of gravity, although you do have terminal velocity. So your velocity won't get to be more than 2.0. And the reason for that was that you were falling off the screen far too rapidly if you started to allow velocity to just keep increasing. So then we add the velocity to the bird's position. This will mean if you're not flapping, then you're continually falling. If now y0 is the top of the screen, so if you've fallen off the top of the screen, we're going to clamp you to it, so you can't just flap off the screen and win the game. And then we've made a function called flap. This sets the velocity to -2. Now, as you saw above, we're adding velocity to fall downwards, so subtracting velocity makes you jump upwards. And rather than adding it to the current velocity, which would mean you had to absolutely pound the spacebar if you want to reverse a hard fall, we're just going to let the bird move upwards right away. And that also means that you can't press the spacebar really, really fast and shoot off the top of the screen. So now that we've created player, all that remains is to add the player into the state that we've been carrying around with us. Also added in a variable called frame time. We'll talk about exactly what that does in a second, but it's important that we set it to 0. We'll be using it to make sure that the game runs at the same speed on different computers. All right, so the play function, instead of just setting you to dead, can be wired up relatively simply. CLSBG sets the screen to blue. Then we add the context frame time ms, which is the number of milliseconds that this frame took to render, to our frame time. If it's greater than frame duration, which I slowed down to 15 frames a second so I could record these GIFs. Normally I have it set at about 30. Then we reset frame time and we apply gravity and movement. So we're not applying gravity and movement in all the times that we're arriving faster than we're ready for the data. That way, if you run it on a slow computer or a fast computer, it renders the physics ticks along at the same speed. And it's pretty important that you remember to do that, because otherwise you can make a game that runs beautifully on a slow computer and is completely unplayable when you give it to your friend who's just bought the latest and greatest gaming rig. Then we use if-let again to see if space was pressed. If the spacebar is pressed, we flap our wings. And we call the player render function we created. I added a press space to flap because it's always a good idea to tell your players what to do. And lastly, if player Y falls off the bottom of the screen height, then we set it to end the game. And on the right here, you can see the game is running. You flap a few times. Eventually, gravity gets the better of you. You're dead. The game is over. And that's actually all you need to model the movement of the bird. So the next element that we're going to look at is obstacles. Obstacles are really a key part of making Flappy Bird an interesting game. If there was nothing whizzing along the screen for you to dodge, then you'd have absolutely nothing to do, and you wouldn't get the horrible impact end game and the adrenaline that keeps you playing. So we're going to go ahead and use a struct to define an obstacle. Now, if you remember, we're increasing the bird's x position every turn. Now, the x position describes, for the bird, is describing how far along in the world I am. For the obstacle, it's also saying where I am in world space, and will then be transformed into screen space with the effect that the obstacle is getting closer and closer and closer to the bird, even though in real terms, the obstacle is staying in the same point and the bird is flying along. We'll worry about that in just a second. We also, if you look at Flappy Bird, every wall has a gap. So we're defining the y position of that gap, and then size is how big is the gap. So when we create a new obstacle, giving it a constructor, we roll a dice with the random number generator and place it somewhere between 10 and 40 on the y scale. That just guarantees that it won't be at the very top or the very bottom, but it'll be on the screen. And then we're using the max function to pick the larger of 2 or 20 minus the current score. So what you can get is when you're just starting out, you have nice big gaps as you're playing. As you play, get more past more obstacles, your score goes up and the game gets harder and harder. But we don't want it ever to become completely impossible, because that gives you a maximum bound of what score anybody could ever have. So we set 2 as the lower ceiling of that, which will give you a relatively small gap, but still playable. And hopefully you can still get a little bit of competition between people for how high can my score go. So rendering the obstacles is a little more complicated. So I put in this graphic, actually from the book, showing you how the gap is defined. So gap Y is defining the center point of the gap, and then there's going to be above it half the size in the top half of the gap, and below it half the size in the bottom half of the gap. So we start off by transforming screen X, which is the current X minus the player X. That gives you the effect, once again, of moving the world around the bird instead of vice versa. Calculate half size. We're using half the size. Makes sense to just calculate it once. Most of the time, the compiler optimizer will notice that you're using it twice and not penalize you, but it's always good to be clear. So for the top half, we draw from 0 all the way down to the gap minus half the gap. I picked red and black pipes. You could really use anything you want. And then again, for the second half, you take the gap Y plus half the size, and you draw down to the very bottom of the screen. And then we create a function called hitObstacle. Once again, we calculate half the size. Does X match is saying, is the player adjacent to the wall? If the player is not, there's no point in really calculating anything else, because if the player is not next to the wall, they can't hit it. Then we check, is the player above the gap or below the gap? As if X matches, and you're either above the gap or below the gap, which is what the OR symbol is telling you there, then you've smacked into the wall. Game over. You return true. Otherwise, you return false, and the bird keeps flapping. So once again, in the state, you store your obstacle. In the new, you create a new obstacle at the very right-hand side of the screen, so that you don't start needing to immediately flex your reflexes. I've also introduced a new variable called score, because you saw it in the obstacle. And so when you create a new game, you set the score to 0. You also repeat this code in restart. Over in the tick function, it's actually pretty simple to wire this up. You add obstacle render to the tick function, and it renders the obstacle. Then you check if the player X is greater than the obstacle's X, add 1 to their score because they've passed the obstacle, and make a new obstacle. Again, at the right-hand side of the screen. And then when you're checking to see have they fallen off the bottom of the screen for gravity, it's or have they hit the obstacle. If they have, then it's game over. And that's actually all you need to get a functional Flappy Bird. However, it's kind of ugly, so we're going to take a moment to turn this into a much prettier game. The biggest change here was that I explicitly set the score to 0 because I forgot to do that earlier. And then on display, in the play function, when it tells you press space to flap, we've added a line, print the current score. Now, you'll notice this uses the format macro, which is one of the really most beautiful macros in Rust. You can format just about anything. The amount of control that you get is incredible. And we've extended the dead function to say, you are dead, you have earned placeholder points, with the placeholder being filled with self.score. That's simple, but it's very useful. You should always reward your player. You get a great endorphin rush when you see your score going up. All right, so this is the ugly version. As you can see, you can flap, you can play. And we hit the wall. You're dead. You earned 1 point. So now let's add some graphics. Bracket lib by default works with a PNG file containing the current font. They're monospaced because I'm emulating an old style screen terminal. And the quickest and easiest way to add graphics is to take that font and replace some of the characters. For example, you can see here we have a wall character. We have multiple frames of flapping bird. And we have an obstacle. And the ground goes at the bottom. All of these came from opengameart.org, a site I highly recommend. When you do search there, make sure that you see the license and pick a license that's compatible with what you want to use. These were all Creative Commons 0, meaning use them for whatever you like. So animation frames, like you saw, there were a total of 4 graphics there representing the dragon, and they run in order. So you start off with the dragon with his wings up, then down a little more towards the bottom, starting, and then you go back the other way. When you combine these together, you get a nice bouncing, flapping dragon. So in the game, we define a constant array called dragon frames, just listing the characters on the character indices on the font map. The source code for all of this will be up in a second, so don't worry too much about following along. And we extend the player to list the current frame. And obviously we set that to 0. And now there's a slight change to the way we're rendering things. We have to tell it to use the new font file, add in a simple console, and I've added also a fancy console. Now consoles layer on top of each other, so you have it's much like Photoshop layers. And what you'll see is that the simple console layer renders exactly the same as the game so far, but the fancy layer lets you specify a lot more information about how and where you want to render the dragon. So you'll notice there's one change here. We have made y a floating point variable. You saw before in the ASCII version that the bird moved very stutteringly, very jerkily. Well, let's make that smooth, and to do that, all we really have to do is make velocity into a float instead of a y. Likewise, for in gravity and movement, we've just had to update a few things to use floating point numbers instead of integers. We've also storing frame. This is the current animation frame. We set it to 0, if you remember. It adds, every time we render the dragon, we add 1 to it. And the %6 is modulo 6, which is the same as a remainder. The frame numbers will go 0, 1, 2, 3, 4, 5, and then back to 0. This will get you your animation cycle running continuously. Because we're not actually tracking where exactly your wings are at any time, we don't really need to worry too much about where it is for collision detection or anything like that. But this does make the game a whole lot prettier. In the player render, because we're using the second console, you have to call active console 1. Like I said, these are like Photoshop layers. So layer 0 is the base text. Layer 1 is set aside just for the player now. Now, set fancy is just like set, except that there's a whole lot more options. The positions are in floating point, so point F instead of just point. And self.y is now a floating point. We are not going to rotate it or scale it. We're calling white with a dark blue background, and we're pulling the character to render out of frame. And because we changed layer, it's a good idea to change it back at the end, because otherwise you might forget and wind up with text all over the place. So with those minor changes, you've turned your ASCII version into a pretty creditable game. I've put all of the source code for this up on handsonrust.com. The game itself is one change away from WebAssembly friendliness. I'll be posting an article on that next week. And this is, like I said, the third chapter of Hands on Rust. I hope you've enjoyed it and gained something to gain something that you feel like you can build, and hopefully inspire you to go forth and make something cool. And to help you make something cool, we're going to have a look at the Rust game development ecosystem. So full disclosure, first of all, Amethyst are actually the sponsors of 2 of my open source projects, so I have to say nice things about them. Fortunately, that's pretty easy because they are actually a really great bunch of guys, nice to work with. Now we're going to focus initially on the Amethyst engine and the Bevy engine. But first, what don't we have? This is something I get asked a lot, and Rust at this point does not have what I'd call a batteries included engine like Unity, Unreal 4, or Godot. I don't know if you've used Unreal, but it's really quite amazing. The first time you pull up the editor, download some marketplace assets, drag a dragon onto the screen, drag a jeep onto the screen, scroll out a bit of terrain, hit play, and you've got an animated flapping dragon who doesn't do anything, and a jeep on the screen, and you can move the camera around. And then with a bit of drag and drop, you can turn that into a playable but simple game pretty quickly. So unfortunately, Rust does not have that yet. What it does have is plugins for both Unity and Unreal that let you write Rust code that interface with the Unreal or Unity engine and provide some of the safety, which is especially useful when you're writing in Unreal. Now, the only downside is you can get into second system syndrome. Sorry, that's a tongue twister. Where you've defined everything in Rust, it looks beautiful, and then you have to make sure you output everything into Unreal. That's a really common problem when you're calling things cross-language. You do wind up duplicating yourself a little bit, actually, as you saw in the previous excellent talk. But Rust is gaining a lot of popularity amongst game developers in general for making tools. It's not really there yet for making a full-featured next Assassin's Creed, but it is getting there. So both Amethyst and Bevy are entity component systems based. Now, what an entity component system is it's a way to represent most of your game as data and decouple having functions attached to all of your data. Instead, you have systems that treat your ECS like a SQL database. So you might say, I want to apply gravity, so I need all entities that know where they are in the world and don't have a tag indicating that they can fly. So then your system would go through and apply a downwards momentum to every item. Now, Amethyst and then Bevy also extend this a bit by providing you with a bunch of pre-made components. So you could say that orcs have a display component that makes them look like a nasty little green critter. They have a position component, but then you would write some game logic that says, look at all the position components. If they're find things that are adjacent, and they attack each other. And so Amethyst is currently in the process of being rewritten. The first version used specs. It's currently rewriting to Legion. It is quite popular for 2D and 3D systems, and you can make some really quite advanced stuff with it. The tutorials are pretty decent, and the Amethyst community are extremely friendly. Now, Amethyst is a very slow trajectory for development. They take their time. They try to make things work when they release them. So if you want to spend a long time on a project, Amethyst is pretty safe because the chances are they're not going to pull too much of the rug out from under you. Now, the slow trajectory upset and bothered a few people, so Bevy came along. The primary author of Bevy describes it as being Amethyst 2.0. I know there are some discussions between the groups. It may yet be Amethyst 2.0. And it is under massive development. Pretty much every time I look at Rust game dev forums, something new with Bevy has come out. And that is amazing. It's also really frustrating if you're trying to make a large project with it. I would recommend waiting a little bit because you either find yourself having to freeze and stick to a certain API level, or you find yourself rewriting things quite a lot. And that's inevitable in the early stages of any sort of engine, but it does make for a rather frustrating time. Now, Bevy is becoming very popular for 2D and simpler 3D games. I've seen everything from 3D chess to Pong to missile defense written in it. It's got some really nice tricks like hot reloading. They're really working hard on user interface layer, and the intent is that once the UI layer works, you'll start to get an editor. And the editor is partly inspired by one Rust project that I recommend keeping an eye on, RG3D. Just like Amethyst and Bevy, it's free, open source, no cost, Libra and Libra. It's also under heavy development. And it's already hit the point that they have a functional 3D editor, map editor, a certain amount of network code, and you can make beautiful looking first-person shooter type games, or third person, that look like the screenshots you see on the right. They have really been coming along fast and furious. Every time I look at their website, they're producing something more beautiful. So the idea is that eventually some of this technology will end up in Bevy and or Amethyst. For now, if you want to live on the bleeding edge, this is a project to watch. All right, wrapping up. As I mentioned a couple of times, I'm the author of Hands on Rust, Effective Learning Through 2D Game Development and Play. That's quite a mouthful. I've put the source code for everything in this presentation, and I'll be putting the slides up later on handsonrust.com, the book's website. Now, the book is in beta, and I personally thought it was kind of weird the books have a beta. I'd never heard of that before, but the growth of ebooks makes this possible. So version 1 comes up. Everybody who buys the book is guaranteed to get all of the future versions, including the final release, just as an ebook. But they're kind enough to send me errata and bug reports. So successive versions have been getting better and better. We're up to beta 6 now. It's currently off with the slightly serpentine process of production, which is how it becomes a final, hopefully beautiful layout, properly laid out and spelling corrected ebook. And it will also be available in full color on paper. Right now, you can get the beta on pragprog.com. If you use the coupon RustLinz, that'll get you a 10% discount for the next month or so. The print version you can pre-order on Amazon, Waterstones, your favorite bookseller. Should be available either late June or early July, depending on how bad my spelling is with the copywriters. All right, if you need to contact me, I am at Herberticus on Twitter, the Bracket on Reddit, and I'm in the Discord. Before I go to questions, I'd just like to say thank you so much for having me. It really is an honor to virtually travel around the world and talk to people who love the same things I do. I'm hoping when there's less of a pandemic issue, that I can hopefully come and do some of this in person. All right, thank you.
Thank you so much, Herbert. Thank you very much. It was a really inspiring talk, and just to share one piece of feedback that we got, you see, Ewald was talking, wow, this was really eye-opening. I really enjoyed it. It was so interesting. You know, let me give you a quick personal background. As one of the mentors of the Coder Dojo Linz, the programming club for kids, I spent every single week many hours with pupils, starting at, let's say, 8, 9, something like this, building simple games. So I 100% agree to your saying that building simple games is a great way of learning languages. And I very much enjoyed what you showed us with Flappy Bird. So yeah, I think you just changed my mind about whether we should try Rust even for relative beginners. And that is my first question to you. What do you think, compared to all the language that you have learned, what is the amount of experience that a young coder should have, in your opinion, to start learning Rust? Is it a good first language? Is it a good second language? Should they already learn C before they approach Rust? What is your point of view on that? I would love to hear that.
All right, so I actually spent the last couple of years helping a whole lot of people learn Rust, which is fantastic. And my experience so far is that it's a great second language. Your first language should probably be something like Python, Basic, something simple enough that it won't bite you too hard while you're still figuring out what is a variable. Because Rust is a great ergonomic language, but it doesn't have, at least until the publisher lets me write it, it doesn't have something to really come in with what is a variable, what is a loop. And you kind of need to know that before you get into Rust. So it's a really good idea to start with something like Python, make something simple, and then when you feel like you're ready to make your second game, Rust is right there, and you realize, okay, so Rust really does abbreviate everything. So, FNs and muts and everything everywhere. But it's not so scary because I've seen all of this working in another language. And also the Rust ecosystem is coming a long way. I mean, Clippy has got to the point now that for half the common mistakes, it tells you not only you did this wrong, but here's the correct version. And so I think, Rust is very close to that tipping point where it'd be a good first language, but we're not quite there yet.
Mm-hmm. Mm-hmm. Yeah, I'm with you. We do a lot of work with the JavaScript language for kids. So we start with online development environments, and maybe Rust would really be a good second language. My second question would be, I don't know a tool for beginners. I love web-based development environments. Do you know of any web-based development environments with which a beginner could build a simple program without having to set up the entire tooling and Rust and installing Visual Studio Code and things like that? That's kind of a hurdle, and I would love to hear your thoughts on how we can make it as simple as possible for beginners to get Rust running on their machine.
For basic console-based programs, on the main Rust website, there's a Rust playground. I actually use this all the time for just demoing something quick and simple. It's not so good when you want to make something complicated. If you just want to show off a concept, It's great. Mm-hmm. Now, I wish I could remember the link. I'll try and find it and send it to you. But there was a fellow a few months ago I saw was working on a WebAssembly Rust playground, and it was coming along really nicely. You could start to define much more complicated programs. It compiled them into WASM and then run them in your browser. That right away gives you access to OpenGL, sound libraries, and all sorts of more complicated features. I just wish I could remember the name of it. I'm sorry, I'll look that up.
Oh, thank you very much. Stefan, do you have any questions that you would like to ask or add?
No, I don't have any questions. I'm just so first, I'm very surprised that I'm already here. My kids are asleep way too early now. That's funny sign. And I was able to catch the latter half of the talk, so that was very nice. And congratulations on your book. So I'm a book collector, so I ordered basically every Rust book from every publisher that has printed books. Yours still on my list, but I guess I give the 10% discount a go.
Sounds good. I've always wanted to write a book. My parents are both teachers. I grew up seeing authors as sort of the ultimate people, and so this for me was just a bucket list item. It was something I've always wanted to do, and so far I'm just enjoying every minute of it.
Cool. So it's your first book?
It's my first printed book.
Yeah.
I've written lots of articles, but
okay.
Awesome.
I'm curious if you ever have the urge then for a second book, because I guess when it's out, it feels like just like I said, a bucket list item, my milestone, and I wonder when you get the itch again for a second book.
I've got to tread carefully on that one because I'm NDA'd.
Say again?
So I can confirm that there is a book, but I can't tell you what it is.
Okay.
Ah.
Cool. Already.
Yeah, they actually approached me before I finished this one. So
Cool. That's great. Looking forward to that.
I've written 2 books, and I had exactly the same situation. I said yes to the second book before I really finished the first one, and I wasn't really aware of what I'm saying yes to. But at the end, it was pretty nice. Yeah, writing a book is really a lot of work, but it pays off. It's really a nice thing.
yeah, it's fun.
Okay. I think with that, we are through. If I take a look at the watch, we hit today the 2-hour mark that we have set for our meetup. Exactly. It's 7:30 here. And yeah, Herbert, at this point, we have to say thank you very much for this talk. We really enjoyed it. And whenever your book is ready, or when you have something to tell us about your second book, whatever, you're always welcome as a speaker here at the Rust Meetup Linz. Thank you very much for virtually traveling from the United States to Linz.
And I will pop into the Discord in a few minutes. I have to run across town first, and I'll post links to the slides and the code there.
Oh, that is very nice for you. Thank you. Thank you very much.
Yeah, thank you.
Okay, very good. And that was it for today. We are done for today's Rust Linz meetup. Don't forget, our next meetup, the next meetup will be on the May 27th, 2021. And we are looking forward to see you all in May for 2 talks by Lisa Passing about creative Rust, and by Harald and Katharina for about why they use Rust for medical visualizations. With that, we would like to say thank you very much. See you in May.
Got
Bye.
2 more things. One
2 more things. Sorry.
Yeah. So as you see, this is a totally new environment today that we tried out after using this streaming software also for Global Azure Bootcamp. Please, if you are around in Discord, tell us how you liked it. We tried to make it a little bit colorful, and tell us how the quality is, if that's a way you like to consume our meetup. And yeah, so thanks again to the wonderful speakers of today. So to Jan-Erik and Herbert, it was great talks. It was fun listening to you. Thank you for being there. And don't forget, after we streamed, we are going to cut and produce all this video, put them up on the official Rust channel, so you can rewatch them there as well. Alrighty. That's it from my side.
Thank you very much. Thank you. Bye. See you in May.
Bye.
Bye.